Children, we've already learnt basic concepts of differentiation. If y equals x to the power n, then differentiation of this is dy over dx equals nx to the power n minus 1. And we have already learnt the chain rule. Dy over dx is equal to dy over dt into dt over dx. And we used this chain rule to differentiate a situation like this: y equals ax plus b to the power n, and then the result is n ax plus b to the power n minus 1 into a. This is simplified, mathematically written as n ax plus b to the power n minus 1. Now we will move on to differentiate functions of say y equals e to the power x, sin x, cos x, tan x, tan inverse x, and the product rule and the quotient rule. Those concepts we will be studying with this. So we will start with y equals e to the power x. Y equals e to the power x is an exponential function. The particular characteristic of this is the gradient of this function is same as the function itself. In other words, dy over dx is equal to e to the power x itself. Right? Proof of this is not required here, but we should know the concept. If y is equal to e to the power x, then the dy over dx is equal to e to the power x itself. If y is equal to e to the power ax, then we can say dy over dx is equal to e to the power ax itself into the coefficient of a. X, the coefficient of x, that is simple a. So this is written as a e to the power ax. We can prove this using our chain rule. Y equals a e to the power x, e to the power ax. We will take this ax as t, then y is equal to e to the power t, dt over dx is equal to a. The chain rule says dy over dx is equal to dy over dt into dt over dx. Dy over dt is, when you differentiate this, it is et itself. We learnt it here. And then when you differentiate, when dt over dx, we have shown here as a. So e to the power ax, e to the power t means e to the power ax into a e to the power ax. And further, if there is a function here as the index of e, so y equals e to the power of x will give you dy over dx equals e to the power of x into the differentiation of this f dash x. So e to the power of x into f dash x. Whatever you find here is differentiated and apply here. We will look into few examples of this. If y is equal to e to the power 3x, e to the power 3x into 3. This is algebraically written beautifully, 3 to the power 3x. Second one, y equals e to the power minus 2x. So e to the power minus 2x and into minus 2, the coefficient of x. This is minus 2 e to the power minus 2x. If it is e to the power 1 over 4x, this will be dy over dx will be e to the power 1 over 4x into 1 over 4. So 1 over 4 e to the power 1 over 4x. Y equals e to the power minus 1 over 5x. Dy over dx is equal to e to the power minus 1 over 5x itself into this coefficient minus 1 over 5. So this could be written as minus 1 over 5 e to the power minus 1 over 5 x. We look into some more examples. Y equals e to the power 2 over 3x. This will give you e to the power 2 over 3x into 2 over 3. 2 over 3 e to the power 2 over 3x. Y equals e to the power 3x plus 2. Now this is like fx type. E to the power fx is e to the power fx into f dash x. So e to the power 3x plus 2 itself into differentiation of this function is 3. So 3 e to the power 3x plus 2. When you differentiate 2, it is 0. Y equals e to the power x squared plus 2. So gy over gx is equal to e to the power x squared plus 2 itself into differentiation of this function 2x. So it could be written as e to the power 2x into e to the power x squared plus 2. Y equals e to the power x squared plus 3x plus 2. Gy over gx is equal to e to the power x squared plus 3x plus 2 into the differentiation of this function x squared plus 3x plus 2. When you differentiate x squared, when you differentiate is 2x. When you differentiate 3x, it is 3. 2 when you differentiate 0, we don't write it. So 2x plus 3 e to the power x squared plus 3x plus 2. We look into a few more examples. If we have y equals e to the power 1 over x to be differentiated, first of all we will algebraically process it as y equals e to the power x to the power minus 1. 1 over x could be written as x to the power minus 1. So you differentiate it now. E to the power x to the power minus 1 into minus 1 x to the power minus 2. So minus 1 x to the power minus 2 is minus 1 over x squared. I took it to the front. Minus 1 over x squared e to the power 1 over x. If we take another example, y equals e to the power 1 over x plus 2. Again algebraically we process it so that we can differentiate. Y is equal to e to the power x plus 2 to the power minus 1. Gy over dx is equal to e to the power x plus 2 to the power minus 1, and then when you differentiate x plus 2 to the power minus 1, minus 1 x plus 2 to the power minus 2. So this could be written as minus 1 over x plus 2 squared into e to the power 1 over x plus 2. Here we use that chain rule, right? Y equals e to the power 1 over x plus 2x plus 1. So dy over dx is equal to e to the power 1 over x plus 2x plus 1. When you differentiate 1 over x, as we did earlier, it is minus 1 over x squared. When you differentiate 2x, it is 2. When you differentiate 1, it is 0. So 2 minus 1 over x squared, 2 minus 1 over x squared into e to the power 1 over x plus 2x plus 1. Right. Next we will move on to the differentiation of Ln x. This is a logarithmic function to the base e. If y is equal to Ln x, then the differentiation of this is equal to gy over gx equals 1 over x. Dy over dx is equal to 1 over x. So if it is y equals ln fx, another function of x, then dy over dx is equal to 1 over fx into f dash x. You differentiate this function and multiply 1 over this whole function into the differential coefficient of this function fx. Right? We can prove this using the chain rule. So y equals ln fx. Let t be fx. So t is equal to fx. Then y is equal to ln t. dt over gx is equal to f dash x. dy over dy over dt is equal to 1 over t. So dy over dx is equal to dy over dt into dt over dx. 1 over t into f dash x. So 1 over t fx means f dash x. 1 over fx into f dash x. Y equals ln x plus 1. So 1 over x plus 1 into 1. Y equals ln 3x plus 4. So 1 over 3x plus 4 into, when you differentiate this one, 3. So 3 over 3x plus 4. Y equals ln x squared plus 2x plus 1. So 1 over x squared plus 2x plus 1 into, when you differentiate this one, it is 2x plus 2. So 2x plus 2 over x squared plus 2x plus 1. Here we can do a small algebraic simplification. This 2x plus 2 is common and could be written as x plus 1. 2 into x plus 1. This x squared plus 2x plus 1 could be written as x plus 1 whole thing squared. So x plus 1 goes off. Therefore it will be 2 over x plus 1. Y equals ln x cube minus 3. So 1 over x cube minus 3, this whole function, into the differentiation of this function is 3x. So 3x squared divided by x minus 3. Again now you get ln equals y equals ln e to the power x plus 3. So when you differentiate this, 1 over e to the power x plus 3 into, when you differentiate this one, it is e to the power x itself. So e to the power x divided by e to the power x plus 3. Another example, y equals ln x squared plus e to the power 2x. So when you differentiate this, 1 over x squared plus e to the power 2x into, when you differentiate x squared, it is 2x e to the power 2x. So this could be written as e to the power 2x. This 2 is taken out. 2 into x plus e to the power 2x divided by x squared e to the power 2x. Another example, y equals e to the power 2x plus 1 ln e to the power 2x minus 5. E to the power 2x into 2. 1 over e to the power 2x minus 5 e to the power 2x into 2. E to the power 2 e to the power 2x is common, it's taken out. 1 plus 1 over e to the power 2x minus 5. This could further be simplified as e to the power 2x minus 4 divided by e to the power 2x plus 5. We take the common denominator here. Another example, e to the power x squared plus 1 plus ln x cube plus 2x plus 1. So this is two different functions. So we differentiate them and add. When you differentiate e to the power x squared plus 1, it is e to the power x squared plus 1 into 2x ln 1 over x cube plus 2x plus 1. Then you have to differentiate this one and multiply here. 3x squared plus 2. Then this could be written as 2x e to the power x squared plus 1. 3x squared plus 2 divided by x squared plus 2x plus 1. X cube plus 2x plus 1. Right. We'll take another, y equals x squared plus 1 e to the power x squared plus 1 ln x squared plus 1. When you differentiate just x squared plus 1, it is 2x. When you differentiate e to the power x squared plus 1, e to the power x squared plus 1 into 2x. When you differentiate ln x squared plus 1, 1 over x squared plus 1 into 2x. So the final answer is 2x plus 2x e to the power x squared plus 2x over x squared plus 1. 10th example. E to the power x cube y equals e to the power x cube plus ln x cube plus e to the power x. So when you differentiate this one, this will become e to the power x cube into 3x squared. You differentiate this 3x squared plus 1 over this whole thing x cube plus ex. When you differentiate the x cube plus it will become 3x squared plus e to the power x. There should be a bracket here. Right. There should be a plus here. So mistake. Right. So 3x squared e to the power x plus 3. Differentiation of trigonometric functions. If y is equal to sin x, then the differentiation of sin x is cos x. So dy over dx is equal to cos x. Y equals sin ax means cos ax into a. Again we can use the chain rule to prove this. A cos ax. If y is equal to sin ax plus b, then cos ax plus b, when you differentiate this it is a. So a cos ax plus b. If y is equal to sin to the power n x, then you can write this as y equals sin x to the power n. These two are same. So t is equal to sin x you take, then y is equal to t to the power n because this is taken as t. So dt over dx is equal to cos x, dy over dt is equal to n t to the power n minus 1. So dy over dx is equal to dy over dt into dt over dx n t to the power n minus 1 into cos x. N t to the power n sin x sin n minus 1 x cos x. If y is equal to sin to the power n ax plus b, then n sin n minus 1 ax plus b into cos ax plus b into a. So this could be written as this. Few examples. Sin 3x means cos 3x into 3 cos 3x. Y equals sin 5x minus 2 means cos 5x minus 2 into 5 cos minus 5 cos 5x minus 2. Sin x squared plus 2 means cos x squared plus 2 into 2x. So 2x cos x squared plus 2. Y equals sin cube x means 3 sin squared x n minus 1 here into cos x. Sin to the power 3x squared minus 1 means 3 sin squared x minus 1 into cos. When you differentiate this it is cos x squared minus 1. When you differentiate this one 2x. So 6, this 2x into this 3 is 6x. Sin squared x minus 1 cos x squared minus 1. Now the example y equals sin 4 minus 5x, then cos 4 minus 5x into minus 5, minus 5 cos 4 minus 5x. Y equals sin e to the power x plus 1, the angle is e to the power x minus 1. So when you differentiate dy over dx is equal to cos e to the power x minus 1. When you differentiate this inside it will be e to the power x. So e to the power x cos e to the power x plus 1. If it is y equals sin ln x, angle is ln x. So when you differentiate it, dy over dx is equal to cos ln x into, when you differentiate ln x, it is 1 over x. So 1 over x cos ln x. Y equals sin e to the power x plus ln x. dy over dx is equal to cos e to the power x ln x into, when you differentiate this, e to the power x plus 1 over x. So e to the power x plus 1 over x cos e to the power x plus ln x. Y equals x squared plus 2 plus sin squared x squared plus 2. When you differentiate this, it is 2x. When you differentiate this, 2 sin x squared plus 2 into cos x squared plus 2 into, when you differentiate x squared plus 2, it is 2x. So 2x into 4 sin squared x plus 2 cos squared. Right. If y is equal to sin squared x, then dy over dx is equal to 2 sin x into cos x. Now you know this 2 sin x cos x is equal to sin 2x. We have a formula from the trigonometry lesson. A differentiation of cos x, it is also exactly similar process. Only difference is when you differentiate dy over y equals cos x, dy over dx is minus sin x. There is a minus coming here. And when you differentiate sin x, it was just cos x. But when you differentiate cos x, it is minus sin x. Remember this minus sign. So all the other things are exactly same as what happened in the sign. Cos ax means minus sin ax into a. So minus a sin ax. Cos ax plus b means minus sin ax plus b into a. So minus a ax plus b. Y equals cos to the power n ax plus b. So n cos n minus 1 ax plus b. When you differentiate cos, it is minus sin ax plus b. When you differentiate ax plus b, it is a. So it will be minus n a cos n minus 1 ax plus b sin ax plus b. When you differentiate cos squared x, dy over dx is equal to 2 cos x. When you differentiate cos x, it is minus sin x. So minus 2 sin x cos x. This is minus sin 2x. We again use that double angle formula. Sin 2x is equal to 2 sin x cos x. Y equals cos 3x minus 2 sin 3x minus 2 into, when you differentiate this, 3 minus 3 sin 3x plus 2. Y equals sin 4x plus 2 plus cos 4 minus 3x. So when you differentiate sin, it is cos, this is 4. When you differentiate cos, it is minus sin 4 minus 3x, this is minus 3. This minus and this minus will make it positive, right? So this will give you 4 cos 4x plus 2 plus 3 sin 4 minus 3. This became plus because of this and this. There are two minuses multiplying, it will make it plus. Then do another example. Y equals cos squared e to the power x plus 2, right? Then dy over dx is equal to 2 cos e to the power x plus 2 into minus sin e to the power x plus 2 into e to the power x. So minus e to the power x, 2 sin e to the power x plus 2 cos e to the power x plus 2 minus ex. We can write this as, using the double angle formula, sin 2 times e to the power x plus 4. Then you get y equals sin squared x minus cos squared x. When you differentiate sin squared x, it is 2 sin x cos x. minus 2 cos x minus sin x. 2 sin x cos x plus 2 sin x cos x. This is sin 2x. Say 4 sin x plus cos into cos x. This is 2 into 2 sin x cos x. This 2 sin x cos x could be written as 2 sin 2x. Y equals cos squared x plus sin squared x. 2 cos x minus sin x plus 2 sin x cos x. So these two will cancel each other. Actually we can see it even without doing this, because sin squared x plus cos squared x is equal to 1. So when you differentiate 1, it is 0. See, y equals cos to the power 3 ln x. So the 3 cos squared ln x into, when you differentiate cos, it is minus sin ln x. When you differentiate ln x, it is 1 over x. So minus 3 over x cos squared ln x sin ln x. Differentiation of tan x. When you differentiate tan x, it will be sec squared x, right? So a proof of this we will be doing once we do the quotient rule. Be patient till that time. There are other ways of proving also, but we are not studying that. Y equals tan ax. Then it will, dy over dx will be sec squared ax into a. Dy over dx is equal to a sec squared ax. If y is equal to tan ax plus b, then dy over dx is equal to sec squared ax plus b into a sec squared ax plus b. Y equals tan x to the power n tan n minus 1 into, when you differentiate tan x, it is sec squared x. So n tan n minus 1 sec squared x. You can show that using the chain rule also. You take t equals tan x, then y equals t to the power n. dt over dx is equal to sec squared x. dy over dt is equal to nt n minus 1. Now we apply the chain rule. dy over dx is equal to dy over dt into dt over dx. N t to the power n minus 1 into sec squared. T to the power n minus 1 is n tan n minus 1 sec squared. T is tan. Right, proved. Let's do some examples on tan. Y equals tan 2x means sec squared 2x into 2 sec squared 2x. Y equals tan 1 over 3x means sec squared 1 over 3x into 1 over 3. So 1 over 3 is taken to the front, 1 over 3 sec squared 1 over 3x. We always write this in front and write it like this, because otherwise this 1 over 3 might get tangled with this angle inside, right? So y equals tan 2x minus 3. So sec squared 2x minus 3 into 2. When you differentiate 2x minus 3, it is 2. So 2 sec squared 2x minus 3. Y equals tan 3 minus 4x. Sec squared 3 minus 4x into minus 4. So minus 4 sec squared 3 minus 4x. Tan x squared minus 3. Sec squared x squared minus 3. When you differentiate x squared minus, it is 2x. So 2x sec squared x squared minus 3. Y equals tan ex plus 2. So dy over dx is equal to sec squared e to the power x plus 2 into e to the power x. So e to the power x sec squared e to the power x plus 2. Tan ln x plus 2. So when you differentiate tan, it is sec squared ln x plus 2. When you differentiate ln x plus 2, it is 1 over x plus 2. So this could be written as rearranged 1 over x plus 2 sec squared ln x plus 2. So for this another example like this, y equals tan ln x squared minus 1. So sec squared ln x squared minus 1 into 1 over x squared minus 1. Again this x squared minus 1 also has to be differentiated and multiplied. It is 2x. So this could be written as 2x over x squared minus 1 into sec squared x squared minus 1. Y equals sin x plus cos x plus tan x. So dy over dx is equal to cos x minus sin x sec squared x. Simple as that. 10th one. Y equals e to the power x squared plus 1 ln x squared plus 1 tan x squared plus 1. When you differentiate e to the power x squared plus 1, e to the power x squared plus 1 into 2x. When you differentiate ln 1 over x squared plus 1 into 2x. Then tan sec squared x squared plus 1 into 2x. So this is the final answer. Now we will do the differentiation of tan inverse x. We will take y equals tan inverse x. Then we can write this as tan y equals x. X equals tan y. Then dx over dy is equal to sec squared y. Ne? dy over dx is 1 over dx over dy. So dy over dx is 1 over sec squared y. Right, 1 over sec squared y means cos squared y. Now we can find the relationship between y and x like this. Tan y means opposite over adjacent. Opposite is x, adjacent is 1. That's a tan x is only tan y equals only x, x over 1. So then the hypotenuse you can find as x squared plus 1 squared square root. Then cos y is equal to adjacent over hypotenuse. Cos y is equal to 1 over square root 1 plus x squared. Then cos squared y is equal to, you get rid of this square root 1 over 1 plus x squared. So dy over dx is equal to 1 over 1 plus x squared. So tan inverse x is 1 over 1 plus x squared. Remember this formula forever. Therefore y equals tan inverse x. Then dy over dx is equal to 1 plus x squared. We'll try a few examples now. If y is equal to tan inverse ex, then dy over dx is equal to 1 over 1 plus e to the power x whole thing squared into e to the power x. This is e to the power x, 1 plus e to the power 2x. If it is tan inverse 2x, dy over dx is 1 over 1 plus 2x whole thing squared. When you differentiate 2x, it is 2. So 2 over 1 plus 4x squared. Y equals tan inverse x minus 1. Dy over dx is equal to 1 over 1 plus x minus 1 squared into 1. This y equals tan inverse 1 over root of x minus 1. So 1 over 1 plus root of x minus 1 squared half, when you differentiate this one, half x minus 1 minus half, because this could be written as x minus 1 to the power half. Half minus 1 is minus half. So you can write this as 1 over x minus 1 root, and then here when you square it will be x minus 1 plus 1 minus 1 goes. Then it could be written as 2x root x minus 1 over 2x root x minus 1. Y equals tan inverse ln x. dy over dx is equal to 1 over 1 plus ln x whole thing squared into 1 over x. So 1 over x 1 plus ln x squared. Now the example tan inverse sin x. So 1 over 1 plus sin x whole thing squared into sin x when you differentiate cos x. So this could be written as cos x over 1 plus x squared. Tan inverse cos x, same thing. 1 over 1 plus cos x whole thing squared into, when you differentiate cos x, it is minus sin x. So minus sin x over 1 plus cos squared x. Y equals sin x plus tan inverse x. When you differentiate sin x, it is cos x, plus when you differentiate tan inverse x, 1 plus 1 over 1 plus x squared. 9th one, y equals sin e to the power x plus tan inverse ln x squared plus 1. Sin e to the power x plus 1 means cos e to the power x plus 1 into differentiation of this is e to the power x, plus tan inverse means 1 plus ln x squared plus 1. When you differentiate ln x squared plus 1, it is 1 over x squared plus 1. When you differentiate x squared plus 1, it is 2x. There should be an x here. I have missed it, 2x. Write it. This is 2x. Then there should be a 2x here also. Right. Then we will move on to a new thing, that is product rule. If y is equal to u into v, here u and v both are functions of x, right? We will see an example. We will first get the rule. When it is like this, if it is a product of two functions of x, then dy over dx is, you just hold one and differentiate the other, and then plus hold the other one and differentiate the other. So u times dv over dx plus v times du over dx. What you do is you hold one and then differentiate the other, plus hold the other one and differentiate the earlier. Right. Let's do a few examples and see. Now here y equals 2x plus 1 into x plus 1. Now this one, we can take u is equal to x plus 2x plus 1, v is equal to x plus 1. When you differentiate u, it is du over dx is equal to 2. When we differentiate v, dv over dx is equal to 1. So dy over dx is equal to u times dv over dx plus v times dv over du over dx. This is the formula. So u is 2x plus 1, dv over dx is 1, v is x plus 1, du over dx is 2. So you can simplify it a little bit more. 2x plus 1 into 1 is 2x plus 1, x plus 2 into 2x plus 2. So 2x is 4x, 1 plus 2 is 3. This is the final answer. We'll take another example. X squared, y equals x squared plus 1 into 1 minus 3x squared. Du u is equal to x squared plus 1, v is equal to 1 minus 3x squared. So du over dx is equal to 2x, dv over dx is equal to minus 6x. Then dy over dx is u times dv over dx plus v times du over dx. So u times x squared plus 1 into dv over dx is minus 6x plus 1 minus 3x squared into 2x. So you can algebraically simplify it by taking this 2x is common, take it out and then simplify it. y equals x squared plus 1 into x plus 1 squared into x minus 1 cube. U is equal to x plus 1 squared, v is equal to x minus 1 cube. So du over dx is 2x plus 1 to the power 1. dv over dx is 3x minus 1 to the power 2. So dy over dx u times dv over dx plus v times du over dx. So I am writing this formula each and every time so that you can remember it. Right, when you are doing also each and every time you write this, then you will never ever forget it. X plus 2 squared into 3x minus 1 squared plus x minus 1 cube into 2x plus. So who are the common guys here? The easiest way to simplify is to pull out the common guys. That's an x minus 1 to the power 2, x minus 1 to the power 3. So x minus 1 to the power 2 is common. Take that guy out. X plus 1 is here, x plus 1 squared is here, you take that guy out. So x plus 1 into x minus 1 squared, 3x plus 1, 2x. So when you simplify it, it's this. I think you can do this. I don't need to elaborate on that. We'll save the time. So y equals x into root of x minus 1. That is u equals x, v is equal to root of x minus 1, du over dx is equal to 1, dv over dx is equal to half x minus 1 to the power minus half. So dy over dx is this formula. So x times half x minus 1 to the power minus half plus x minus 1 to the power half into 1. This could be written as x over 2x minus 1 plus x minus root. Then you take the common denominator here. Then when you multiply these two together, the square root will be vanished. So x plus 2 into x minus 1. So when you simplify it, 3x minus 2, 2 over x minus 1 root. Then there's another y equals x minus 1 root plus x plus 1 squared. So du over dx is equal to half x minus 1 to the power minus half. dv over dx is equal to 2x plus 1. dy over dx is equal to u times this. Right. Then we will apply the formula x minus 1 to the power half into 2x plus 1 plus x plus 1 squared into half x minus, right, and then we can put this guy down and then we can simplify it in this way. We'll do this example also. Y equals e to the power x, x plus 1, u equals e to the power x, v equals x plus 1, du over dx ex itself, dv over dx is equal to 1. Then e to the power x into 1 plus x plus 1 into e to the power x. E to the power x is common. Then e to the power x, x plus 2. E to the power 3x plus 2x into 2x minus 3. U equals e to the power 3x, v is equal to 2x minus 3. du over dx is equal to 3 e to the power 3x. dv over dx is equal to 2. Then e to the power 3x into 2 plus 2x minus 3 into e to the power 3x into 3. E to the power 3x is common here. Pull that guy out. It's on 2, 6x minus 9. E to the power 3x, 6x minus 7. Y is equal to e to the power x sin x. Then du over dx ex, dv over dx is equal to cos x. And then ex into cos x plus sin x into ex. Ex is common, take it out. So ex into cos x plus sin x. And then y equals e to the power 2x into ln cos x. all possible examples I am including. du over dx is equal to e to the power 2x plus into 2. dv over dx is equal to 1 over cos x minus sin x. Then e to the power 2x plus 1 into minus tan x. This is sin x over cos x minus tan x. v is equal to ln cos x into 2 e to the power 2x plus 2. E to the power 2x plus 2 is common, take it out. This is minus tan x plus 2 ln cos x. Then y equals sin squared into cos cube. du over dx equals 2 sin x cos x. dv over dx is equal to 3 cos squared x minus sin x. Then you apply it here. Sin squared into minus 3 cos squared sin x. Then cos cube 2 sin x cos x. Now here sin to the power 3 minus cos squared, and then cos to the power 3, cos to the power 4 sin. So sin x is common, cos squared is common, so you pull them out. When you pull them out, it will be minus 3 sin squared here. Here what will remain is 2 cos squared. Now you can write this cos squared as 1 minus sin squared. This sin squared as 1 minus cos squared, and then simplify it like this. Quotient rule. Here we divide u and v. U over v. Here the order is very important. Numerator is u, denominator is v. U over v. Then dy over dx is equal to v times du over dx minus u times dv over dx divided by v square. This order is important because there is a minus here. In the product rule it wasn't a problem, it was plus. We'll see some examples. Y equals x over x plus 1. U is equal to x, v is equal to x plus 1. du over dx is equal to 1. dv over dx is equal to 1. So v times, you can x plus 1 times du over dx is equal to 1, u minus x times. So this will be 1 over x plus 1 square. This simplification I think I don't need to elaborate much on. Then u is equal to, in this example, u is equal to 2x plus 3, v is equal to 3x minus 4. So du over dx is equal to 2, dv over dx is equal to 3. So when you apply in this formula, 3x minus 4 into 2 minus 2x plus 3 into 3. So when you simplify this, it will become minus 17 over 3x minus 4 whole thing square. This simplification I think not that difficult for you to do. Right. Y is equal to x plus 2 squared, x minus 2 squared. So x plus 2 squared means 2x plus 2, dv over dx is 2x minus 2, you apply it here, x plus 2, x minus 2 squared into 2x plus 2, x plus 2 squared into 2, x minus 2, and then x minus 2 whole thing squared. Then this will be to the power 4, 2, x plus 2, x minus 2 is common, then do this, then you get minus 4 to the minus 8 to x plus 2, x minus 2 goes off, then to the power 3. This simplification I think you can understand. This into this is minus 8, this and this goes off, x plus 2, right. Y equals tan x. I told you when it is sec x, we will be proving it when we are doing the quotient rule. Now here the opportunity. Tan x would be written as sin x over cos x. So u equals sin x, v is equal to cos x. du over dx is equal to cos x, dv over dx is equal to minus sin x, so the v times du over dx minus u times dv over dx over v squared cos x into cos x minus sin x into minus sin x over cos squared. So here it is cos squared x, here it is plus sin squared x. Cos squared x plus sin squared x is equal to 1. 1 over cos squared x. 1 over cos squared x is sec squared x. Similarly, we can differentiate cot x also in the same process. U is equal to cos x, v is equal to sin x. Then it will become sin x into minus sin x minus cos x into cos x. This will become minus cos x squared. So when you differentiate tan x, it is sec squared. When you differentiate cot x, it is minus cos x squared. Y equals e to the power x over cos x. E to the power x, this is cos x, so this is du over dx is e to the power x, dv over dx is equal to minus sin x. So you apply in this formula back again, cos x into e to the power x minus sin x into minus sin x. Then e to the power x is common, take it out, cos x plus sin x divided by cos square. Another example, e to the power x over ln x plus this one, e to the power x is e to the power x. When you differentiate this one, it is 1 over x plus 1. So e to the ln x into e to the power x, ex into 1 over x plus 1. And you can take this e to the power x common out. That's the only simplification we can do. Here it is x squared u is equal to x squared, v is equal to 2x plus 3. This is when you differentiate 2x, when you differentiate this it's 2. So 2x plus 3 times 2x and x squared times 2. When you simplify, 2 is common, it will become this 2x into x plus 3 over x squared. 3x plus 1 over sin x. So when you differentiate this, this is 3. When you differentiate this is cos x, and then sin x into 3, 3x plus 1 into cos x. Right. E to the power x. Here this is an interesting case. In the numerator here, e to the power x into x plus 1. This, when you are differentiating in the numerator, you got to apply the product rule back again. So du over dx is equal to x times differentiation of this is 1, differentiation of this times differentiation of ex is ex. So ex is common, take it out, this is x plus 2. When you differentiate v, it is 1. Then v, apply in the formula, x minus 1 times e to the power x, x plus 2, this one, e to the power x, x plus 1 into differentiation of this is 1. So you can simplify this as this. Take e to the power x out. Thank you.